All right, next up we've got balancing redox reactions. Now, balancing redox reactions, there's a process to it. And this is a tricky task, but it's totally doable. The first step in this process is to write the half reactions. So identify which species is getting oxidized, which species is getting reduced. Then you want to balance the other elements, those that are not hydrogen and oxygen. Balance the oxygen with water, and then balance the hydrogen with protons. Balance the charge with the electrons, and then balance the number of electrons between half reactions with coefficients. Add the half reactions, and you're good. Excuse me. Now, there are other circumstances that we'll go into in just a minute, or in probably the next video, and that is for reactions in a base, add hydroxide to neutralize or to balance it out. So those two right there, balancing the number of electrons between half reactions with coefficients, that's pretty tricky. And then consolidating and adding the half reactions is your very last step. Now I'm going to keep a tally up in the right-hand corner, and I'm going to balance one of the questions that I've got. In a particular redox reaction, MnO2. So I'm going to write this down. MnO2 is oxidized to MnO4. So on the reactant side, I've got MnO2, and on my product side, I've got MnO4, and that has a -1 charge. And Cu2 plus is reduced to Cu plus. Complete and balance the equation for this reaction in an acidic solution. So with that in mind, since this is taking place in an acidic solution, we know that this last 8th step, we're not going to be doing that because it's not in a basic environment. The phases are optional. Okay, so the first part of this is I want to write out my half reactions. And with my half reactions, I want to write out, well, how many electrons are going and where are they? So whenever I look at my half reactions, or these kind of bare bones half reactions, what I have is MnO2. What do I know about my redox or my oxidation state of Mn? Well, I know my oxygen, there's 2 of those, that's a -2 times 2, so that's -4 charge. This molecule, do I have a charge up here indicated? I don't, so it has an overall neutral charge. So if oxygen is bringing a -4 charge total, that means Mn has to be +4. Okay, now moving on to the next one. Oxygen is still -2, so 4 oxygens is going to be 4 times -2, that's -8. What plus -8 gets me a charge of -1? Well, that would be +7. So manganese is going from +4 to +7. What that ultimately means is that my half reaction, let's see, manganese going from +4 to +7, that would be an example of oxidation. So MnO2 yields MnO4 minus plus 3 electrons. Okay, now this is my oxidation reaction. I'm going to write ox. My reduction reaction, well, I've got copper 2 plus going to 1 plus. Okay, so that means there's 1 electron. In addition to that, what I also know is that my electron is going to be on the reactant side. Plus 1 electron yields Cu plus. This is my reduction, RED. Okay, now what I want to do with this is I want to go through my checklist. I'm going to take my oxidation reaction where I've got MnO2, and you know what? I'm going to erase what I've written in the upper left-hand corner because I'm done with that. I've taken that and I've expanded it. I've kind of made it a little bit more complete. I might do a little bit more erasing and rearranging, but for the time being, that's what I'm going to do. I want to look at my half reactions. Step 1, those are done. Step 2, balance the other elements. Well, I don't have any other elements to balance. I want to balance the oxygen with H2O. So I'm going to write plus H2O. Now I need a coefficient in front of that because I've got 2 oxygen on my reactant side, 4 oxygen on my product side, so I'm going to say 2 H2O. Okay, so then my reduction reaction, I don't have any oxygen, so I do not have to worry about that, so I'll check that off. Now step 4, balance hydrogen with H+. Okay, whenever I added that water to my oxidation reaction, I definitely did add something. So I'm going to go back and I'm going to write, this is my oxidation reaction, and this is my reduction reaction. Okay, so I've added 4 hydrogens, so I need to balance those, plus 4H+. Okay, now do I have to worry about that in my reduction reaction? I don't. So now what I need to do is balance my charge with electrons. Okay, so if I look at my charges, what I notice is that MnO4 has a -1 charge, 3 electrons on my product side. I'm looking at my oxidation reaction. That's -4. My hydrogens each bring a positive charge, and I've got 4 of those. Those are effectively going to cancel out. Now, the next thing that I notice is that whenever I look at my charges in my reduction reaction, Cu2 plus 1 electron. That gives me a balanced charge of, well, +1 on each side. So my 2 half reactions are done. I've done 1 through 6, and here's what I have to show for it. Now I need to balance the number of electrons between the half reactions with coefficients. So what that means, between half reactions, looking at my oxidation and my reduction half reaction. What I notice is that I've got 3 electrons as products in my oxidation reaction. I've got 1 electron as a reactant in my reduction reaction. So what I need to do is I need to throw a 3 coefficient in front of that electron. But again, I still need to keep this balanced, so I'm going to say 3 times all of this. So now I'm going to update my reduction reaction, and it will be 3Cu2 plus 3 electrons yields 3Cu+. This is still my reduction reaction, but I'm good. Okay, now the next thing that I want to do is I want to account for so that would be, I balance my electrons, so 6 is done. Now number 7, I'm going to add my half reactions. So as a reactant, I've got 2H2O plus MnO2 plus 3Cu2 plus 3 electrons. That will yield, okay, so I've accounted for this. Now I've got my products, MnO4 minus plus 3 electrons plus 4 protons. So check, 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 plus 3Cu plus. So check. Okay, so that accounts for all of my different species. So I have balanced this reaction, and the last thing that I need to do, well, or the last thing that I guess there is left to do that I can do, is to simply look at any species that are found on both sides, the reactants and the products. And you'll see this and this. So we don't need to include that, so my overall reaction is 2H2O plus MnO2 plus 3Cu2 plus yields MnO4 minus plus 4H plus 3Cu plus. That captures everything. I'm able to cancel out my electrons, and that is a balanced redox reaction. I hope this is helpful. Just follow the sequence and you'll be good. Being able to do a problem like this will be particularly helpful on question number 6 of your homework. So, work through that and basically follow this along. All right, have a good one.